What happened was the auxiliary pumping system was knocked out by the tsunami, and the cooling of the fuel rods in the reactor and in the cooling ponds, the circulating water for that stopped, and the water evaporated. Now, what's the consequence of that? The way the uranium is packaged, it's put as little pieces of oxide, actually uranium oxide, except in the one case where it's spiked with some plutonium, inside of a zirconium tube. It's about 12 feet long. These zirconium tubes are packaged into bundles, about 100, and several of these bundles are put into the reactor, and the spent fuel pond has hundreds of these assemblies also. So the uranium, and in one case the plutonium, is encased in a zirconium tube. It's actually an alloy of zirconium called zircaloy, but it's 95% zirconium, and its chemistry is similar to pure zirconium. When zirconium is, when it's operating under normal conditions, that's very protective of the uranium inside. It doesn't spill out, it's non-corrosion, doesn't corrode. But at high temperatures, which you will get in the absence of the cooling, then those zirconium rods will heat up. When that happens, the zirconium will, when it's exposed to water, extract the oxygen from the water, create zirconium oxide and zirconium hydroxide, leaving hydrogen as another product of that reaction. Actually, there's yet another product of that reaction, and that is heat. That reaction is what's called exothermic. So the reaction at high temperature of the zirconium with steam produces heat that exacerbates the problem and hydrogen. The hydrogen has two deleterious consequences. One, hydrogen, even at a few percent concentration in air, can lead to an explosion. And that happened in several places, damaging the buildings. It's unclear if it damaged a containment vessel, but it might have. And it might have also damaged a cooling pond, but we don't know. The hydrogen has another consequence, and that is that it inserts itself into the zirconium metal crystal structure and makes the metal, the zirconium rods, the zircaloy tubes, brittle, subject to flaking and breaking. Now, if they break, then those fission fragments that are producing the energy can be released to the whatever's around it. In the case of the reactors, there's containment. Maybe slightly breached in some cases, but largely contained. But in the cooling pond, there is no containment vessel. So if they overheat and the zirconium alloy fails, you'll get the hydrogen. There's evidence that we know that there was a hydrogen explosion, so we know this happened. The radioactivity produced by the fission process that has not decayed yet is then in the open environment.